Okay, welcome again, guys. Today we'll be looking at elastic load balancer and auto scaling group, and I'll be running you through the very straightforward, simple example of how to go about this. Elastic load balancer (ELB), popularly called ELB, is a service provided by AWS that automatically distributes incoming application traffic across multiple resources such as Amazon EC2 instances, containers, and IP addresses. It acts as a gateway directing traffic to the back end servers or applications that can handle the workload. This ensures that no single resource becomes overloaded, improving availability and fault tolerance. Okay, so the thing about elastic load balancer, as you can see in this diagram, is such that the user who is requesting access to a service, whether it's a website, whether it's a web app or a mobile app, be it the front end and the back end, an elastic load balancer stands in between the user request and the instances. So the point about elastic load balancer really is, AWS supports having multiple instances to meet up the high demands of user requests. So in cases like this, elastic load balancer actually serves this request to the appropriate instances. So for instance, if a user visits a website or a particular address making a request, the elastic load balancer forwards the request to the first instance. Another user will forward to the next instance, another user forwards to the next instance, another user forwards to the next instance, in this kind of sequence. So the whole idea is it tries to balance the load. Now that way, one resource will not just get overwhelmed with traffic and requests. So with this diagram, really, it just makes it simple to understand how elastic load balancer works. So really what you do with it is to distribute traffic across multiple compute resources, helps maintain application availability. That way you don't have downtime. Downtime is really minimal, since there's a mechanism that helps you manage your workload. It automatically scales to handle incoming traffic. So elastic load balancer works very well with what we call auto scaling group. We'll be looking at that shortly. What auto scaling group is used for really is to help manage, is to help scaling and scale out your resources. I'll explain better when we get there. So there are types of load balancers. We have application load balancer, best for HTTP and HTTPS traffic. So this is what we usually use when we visit resources using the HTTP protocol, and this is what we'll be covering in our short course. Network load balancer, this is best for TCP. This is a different type of protocol, and ultra low latency. Gateway load balancer, best for deploying third-party virtual appliances. I think this also handles things around Internet of Things. Benefits of ELB, so it's increased fault tolerance, meaning it helps to manage issues with service availability. So if one of the instances is down, the ELB just automatically direct traffic to the healthy instances. Seamless integration with auto scaling. We'll be seeing how this works. So elastic load balancer works seamlessly with auto scaling group. Health checks, this is where elastic load balancer checks the health of instances, and if any of the instances is having an issue, maybe it's not running properly or it's being shut down or terminated, it automatically redirects the traffic to another instance. So SSL termination, what this does, it helps you at this point. Elastic load balancer decrypts the encrypted data that is being transmitted using HTTPS, so that it can be channeled into the instance properly. So support for containerized applications. So elastic load balancer works really well with all these container applications, so things around Docker. You'll be seeing more of this in future classes. So before we move to auto scaling group, I will quickly like us to touch on how the elastic load balancer works. Alright, in order for this to work as expected, I'll be creating multiple instances. I'll just be creating about 2 or 3 instances so that we can see how elastic load balancer works. So I just want to change my region to US East 2, which is Ohio. Now I have a Git repo where I've dumped some of the script we'll be using in courses. So if you come to github.com/AWS, you can just jump into the ELB. Okay, so the EC2 batch script is what I want to run in this instance. So the whole idea of this particular batch script is just to install HTTPD, which is an Apache server, and echo hello world from the name of the host name. That will be able to differentiate the different instances that we're looking at every point in time. So let me launch a new instance. In a previous course, we've seen where we launched multiple instances and launching instances using user data in the advanced section of this page. So I just call this AWS, and let's say simple web app. I leave the Amazon Linux. We maintain the free tier. I'll just leave the instance type to T2 micro, which is also within the free tier zone. I'll proceed without key because I won't be logging into the server. I'll just enable HTTP, and okay, so I'll just let's enable HTTP, and under the advanced details I scroll down to where we have user data. So the whole idea is by launching these instances, I'll be launching 3 instances. This script will run immediately the instance is booting for the first time. So it will install Apache, and it would echo hello world from the name of the host into a file, HTML, in an index.html rather. So I'm launching this instance. We just pause this video for a bit till this instances are ready. Okay, the instances are running. It's still initializing because of the status check are still ready, but in the meantime we can quickly look at the different IP addresses. So this is the first instance, and it says hello world from 172.3.1.15.202. so that is the IP address, the private IP of that particular instance. Now this is the second instance, which carries a slightly different IP address. You can see that it's changing. Then I go to the third instance, and I have the third instance open. So pretty much this is for us to have a clear differentiation between the different instances that are being launched. So in most cases, what you'll be having running here will be your application, same application running in all these instances. So that's just to show you how that the 3 instances are pretty much different. Alright, pretty quickly we'll just go and create an elastic load balancer. So if you come to load balancers, here you create a load balancer for your application. Now a load balancer requires that you have a target group. Now a target group are instances that you've grouped together and you give it a name within the target group. So first thing first, I'll have to create a target group before I can create an elastic load balancer. Though you can create the target group while creating the load balancer, but for simplicity's sake and clarity, it's nice to first create the target group. So the target group is a way of grouping different instances as one. So I'll quickly delete. There's an existing target group here. I just will quickly delete it to avoid confusions. Alright, so I want to create a new target group. I'll just call this target group it's an instance type, so I just leave it as an instance. I give it a name. I can call it simple-tg, which is target group. I leave every other protocol as default. Now the health check is just to select a path which the target group will check at every point in time to know if the instances are in good health. So just leave the default. The default is the slash, meaning the root directory. So if you were targeting a particular folder, let's say login, you want to be sure that the website slash login loads before you can say the service is healthy. But in this case, let's just leave the default and go next. So now these are the available instances. I could have maybe 100 instances here, but the ones I want to tie together within the same target group are the ones I'll select. So in this case, I'll select all the 3, and as soon as that is done, I'll include pending below, meaning I want to use these 3 as my target group. Then I create the target group. Now my target group has been created. Usually what happens is your target group would first be in a state of checking the health of each of the instances to be sure that they are good. So you can see it's saying unused at the moment. There are none of the target group is being in use. It's saying 0 unhealthy, 0 healthy. So it's checking at the moment to see that the health of the target group becomes healthy. So alright, now that you've created the target group, let's quickly go and create an elastic load balancer. So we'll create an elastic load balancer. So we're sticking to the application load balancer. You give your load balancer a name. I'll just say simple.elb. I pretty much leave everything as default. However, you have the opportunity to select the availability zone you want your instances to run from, so that way it distributes your traffic across this availability zone. So once that is done, you now need to select a security group. So in this case, if you haven't created a security group, now the whole idea of the security group is the same way we allow certain ports to run on our instances. So it's best you create a security group that enables port 80. I want to select one of the security group that I've created, which I know has port 80 allowed and the rest. So at this point, how should it distribute this traffic? So how does it listen and route them? I can now come here and select my target group. So instead of selecting those instances one by one here, it just means that I select the target group. So from the target group, I can add and remove instances that the elastic load balancer will work with. So pretty much that's it. We would want you to leave every other thing as default, and you create your load balancer. Now your load balancer would have been created successfully. This is your load balancer DNS name, so it means that if you want to access your load balancer from the URL, this is the address you'll be using. This load balancer would not open immediately because it takes a bit of time. If you look at the simple target group that you created, all the instances must have been in healthy states before the application load balancer would work. Alright, so when I refresh my target group, I can see that the 3 of them are healthy. If I go back to my load balancer and copy this DNS name and visit it, voila. So the load balancer loads any of the instances that I have created and tied to the target group. If I refresh this, you can see the same address, but it's loading another service. If I refresh, so this just means that it rotates the address, it rotates how it channels the traffic to the instances. Okay, that's pretty much a little instance on how auto load balancer works. It just helps you, ensures that you have your uptime and it's direct traffic to any of the instances as the user visits the website. We'll move straight up to auto scaling group. Alright, welcome to auto scaling. Auto scaling is a cloud computing feature that automatically adjusts the number of computing resources based on the demand or workload. It dynamically adds and removes capacity to ensure applications have the resources they need for performance and availability, while also optimizing cost by reducing idle capacity. Yes. Alright, so this diagram would explain what autoscaling actually does. So for instance, there are pretty few concepts you need to understand. You see here we have minimum size, we have desired capacity, and we have maximum size. So you scale between the minimum and the maximum. So what does autoscaling really mean? So these boxes you're seeing are different instances. So for instance, I want to build a solution or an app that will require very high usage at certain period of the year. So for instance, Black Friday, and people visit an e-commerce site or visit certain promotional websites at a very high rate, so it creates a spike in usage. So if we already had 3 or 4 instances running, how do we manage when there's high demand? So what happened is that the autoscaling group is a resource that, if you've enabled in your architecture, would scale out based on the amount of usage. So you can say what you want is, once a particular instance have gotten to 70% of CPU usage, it should add 2 more instances, it should add 1 more instance, it should keep adding instances till you also have to set the maximum capacities, because you cannot just keep autoscaling infinitely. So this is what autoscaling pretty much is. So the desired capacity is, when you set your autoscaling group for the first time, you need to input, let's say, the number of instances that should start with or should be running at the time you set up the autoscaling group. While the minimum size is okay, if it scales in, it can't scale lesser than, in this case, there are 4 instances, 6 are the desired, and you have additional 6 that you can scale out to as the demand comes in. So it automatically adjusts EC2 instances based on traffic. It ensures application performance and cost optimization. So you can imagine, if at a certain period you are not having high usage in terms of traffic, in terms of workload, it should just reduce to the minimum EC2 instance that has been defined in the autoscaling group. So another example, proper use case, is an organization that runs a very high number of employees. So during the end of the month, you run payroll. So payroll might be a period where there is high traffic between the database and the application that runs the services. So you see a case where, or even employees are at that point logging into their self-service portal to view their payslip. So usually, maybe that period is always high traffic. You can schedule an autoscaling. So autoscaling also could be scheduled to say, on the 24th of every month, let the capacity of our infrastructure increase to 5 instances rather than the 2 or 3 that usually runs on every other day. So it maintains minimum desired and maximum number of instances. So these are components of autoscaling group. During autoscaling group, you attach target group used by your elastic load balancer. So you need to do that. When scaling occurs, new instances are automatically registered to the load balancer. So it means that once a new instance is created during the autoscaling group, it's easy for it to attach it to the target group that is already existing with your elastic load balancer. So it ensures seamless traffic distribution without downtime. Now, for you to be able to use autoscaling group, you also need to have a predefined template. Why? Because the new instances that will be running should run using a particular template. So then you manage your autoscaling group, then you set your scaling policy. Should it be target by tracking? Should it be step scaling? Should it be scheduled scaling? We'll see all these options when we try our hands-on on autoscaling group. So advanced configuration tips is used to warm up period to prevent premature scaling. So you can combine CloudWatch alarms with ACG policies, set lifecycle hooks for pre-launch, pre-terminate operations. So we'll look at CloudWatch alarms in other videos, but this is how you monitor activities within your AWS resources. So one of the things we'll be doing now is to launch a template. We'll create a launch template. So it means that it's this launch template we use in setting up our autoscaling group. And the reason why you need a launch template is, by the time a new instance is starting, what configuration should you use? You can't have instances scaling out and they don't have the default settings or boot files or app containered into the application. So these are into the instance I mean, so following this, my batch scripts, sorry, my GitHub account, you can follow up with the videos. All right, for us to launch an auto scaling group, for us to set up an auto scaling group in our infrastructure, the first thing we need to do is to have a launch template. Now, the launch template pretty much is what is a saved template of EC2 instances that we want to launch in future. So I would call this simple web temp, and I just go ahead and select what the configuration would look like. So I come here, excuse me, I choose my AWS Linux because that's the configuration we used for our service. I maintain the free tier. We will not be I maintain the free tier T2 micro. Will not necessarily be using the key to login, so I can just don't include a launch don't include in launch template. Okay, so I can just select a key. So in this case, there's a key. I choose my security group. I would work with an existing security group. Sorry, just need to select the security group, which is what we've used. I choose my volume. Can just leave the default. That'll go straight to advanced. And under my user data, I go back to copy my script here just as it is, and I'll paste it here. Voila, I've created a launch template. So now usually what I do with what you're to do with launch template is, if you have, all right, so the whole idea is, if you want to create an instance and you don't want to go through the trouble of setting up the configuration, since you'll be using the same configuration all the time, it's just pretty much set up a launch instance, which is what we've done. And I choose this simple launch instance, and I say launch instance from template. So what this means is it would launch a new instance using the configuration that I've saved in that template. So it just loads it, and all I need to do is to click launch instance. However, you can also look through these steps and be sure that everything is as you want it. Even the advanced details, it will have the settings or the script, the batch scripts in the text area. And if, for instance, you need to change anything, you can just change it at this point before you launch the instance. Otherwise, I just launch this instance. So we have a launch template, which means we're ready to create our auto scaling group. So I just scroll down here, click on auto scaling, and brings me to the auto scaling group page. Here I choose enter a name, and I choose my launch instance. In this case, we have simple web temp, and it shows me the details of the launch instance, the image, the AMI ID, the security group that I had selected, the instance type, and I go next. So here I can choose a VPC, so we'll just stick to the default. Availability zone, here you need to select all the availability zones so that your instances can work well with the auto scaling group. Can work with the elastic load balancer, and it can distribute traffic across this services. So now how do I balance the load? Do I just say no load balancer? Here would have to start creating a target group all over again. However, I can attach this to an existing load balancer, which in this case would help attach to an existing load balancer. What this would do is it will make me use that my load balancer and the target group. So it means that for every new instances that the auto scaling group creates, it would route it through the existing load balancer and ensures that it's within the target group of that load balancer. So once I have selected the integrating with other services, I go next. Here it now asks you what is your desired capacity for your auto scaling. I might want it to just be 2. Then it will tell me what is the minimum desired capacity. Yeah, I might want a situation whereby once there is no traffic, it scales in to as much as 2 as well. Then what is the maximum desired capacity? Meaning that, okay, as soon as we're having high traffic, there's a spike in the compute resources, or there's so many workload that is being run by the instances, it should add another instance, add another instance. But as soon as it gets to 5, this auto scaling should stop. So I'll leave every other option as default. So go next. Now this is notification. So for instance, if sorry, let me go one step back. And so target scaling policy, sorry I missed that. So no scaling policy means that it remains in the initial state, will not dynamically resize to meet demand. So now here I want to specify that as soon as my CPU usage has gotten to 70%, meaning that my compute, my instances as they are running, once the capacity has gotten to 70%, it should scale in. So these are other options you can use. It could be based on network traffic, it could be based on a CloudWatch matrix that you've set, but on the average, just let us select the average CPU usage. So with this target tracking scaling policy, it just means that as soon as our instances have gotten to 70% CPU usage, the auto scaling just kicks in and initialize another instance. So now to add notification is to just say once a new instance is being launched or terminated, you can set a notification. I already have a service here, but we'll look at notification much later. But it could just be a case of, oh, do you want to get notification when an instance is launched or when it's terminated? I might just want to get instance when an instance fails to launch. That is when I want to be notified, so I know something is wrong. Or maybe when an instance is terminated due to hardware failure or what have you, I want to be notified. So but let's ignore notification for now, and I move straight to tagging. Tagging is just for you to tie your application to simple web app. Just create tags to identify your your auto scaling group. So here I can review everything, and once I'm satisfied, I create the auto scaling group. Now what this does, immediately this auto scaling group is active, it launches the number of instances that I have said it should launch in the desired settings. So let me quickly come here. You can see pretty quickly there are 2 instances that have been initialized. They don't have a name yet. We didn't label them properly anyways. So but you can see that 2 instances have been initialized, and these 2 instances have joined the existing 3 instances that we have. If I go to my target group, sorry, just a second. Initially our target group had just 3 instances, so I'm sure if I give this some time, you see additional instances would have joined the target group. So this is how you can know that your auto scaling group is being configured properly. So just try out 1 or 2 things, and it's important to note that once you're done with this practice, you have to terminate the auto scaling group. Now you can see the system says 4 of the instances are healthy, 1 is unhealthy. Let me check why. Let me see what must have happened to the instances. Maybe one of them is still loading. So okay, it appears they are all running, but just like we had said about the target group, it checks the health of the instances and ensures that these instances are healthy before they are available for the elastic load balancer to display. So as it is, if I come to my elastic load balancer while that is loading and I refresh, it just keeps changing. I can see IP addresses that I didn't have before now, so the compute is generating across the 5 instances that are currently running. All right, so just to give you a simple example of what these instances should do, there are other ways we can try some scripts that would stress the servers and let the CPU usage hit 70%, and we wait and see the instance launch a new one. And if you look at it from our examples, our maximum capacity for instances are 5, so it means that no additional instances can be created. Now let's say for some reason something goes wrong to all the instances, or somebody accidentally terminates all instances. Now I'm terminating all the instances, and you see the instances will run from the shutdown state. I'll keep refreshing this as I'm explaining this, so that you can see how once an instance is being terminated, another set of instance would be initiated immediately. So that way we don't have to have a downtime. We're not seeing cases where all the instances will be terminated, by the way, but just so that you can have a feel of exactly what it is. So now you can see one instance has been terminated. If I refresh this, so while I'm refreshing, you can see another instance has started running. So which means that as these instances are terminated, an instance has been initiated to backup. So if I refresh this, you can see that a new instance has been launched. Let me come back here and refresh. Because we had minimum of 2 instances, so you can see that both instances are running. So the whole idea is that as long as the auto-scaling group is being configured properly, there will be no downtime. At every point in time, 2 instances will be running. So if we decide to stress our servers and they have so many workload respectively, as each of these instances hits the 70% threshold in terms of CPU usage, a new instance will be launched. So that's about it on auto-scaling. Alright, in order not to incur cost, it's best that you remove the auto-scaling group, because no matter how much you terminate these instances, the auto-scaling group will keep relaunching it for you. So let's go back to auto-scaling group and delete auto-scaling group. That way you can terminate the instances that have been created without issues. I go to my target groups, so I delete this target group. Okay, so I have to delete the load balancer before I can delete the target group, because it's still is associated to the load balancer. So I go ahead to delete the load balancer. Then I can delete the target group. Alright, so once that is done, I'm just cleaning up my entire resources, so I can now terminate these 2 instances. Now, since you'll be practicing AWS, it's always best to delete all your resources so that you don't incur costs. And like I've always mentioned, we try to stick to resources that are around the free tiers. There are some services like the Elastic IP and some other things we'll be talking about that might incur little cost, but we'll let you know when we are there. And as soon as you've tried it out, tried an example, you delete your resources. Alright, thank you for watching this video. I'll see you in the next.